Good morning, and thank you for joining us this morning, or if you're watching this in a recording, thank you for this. This is the third in our series of Glow Meets with Primary Engineers and Leaders Award. This morning we have Gordon Masterton with us from Jacobs.
Right,
who's going to be speaking to us today. I'm not going to talk too much about that because I'll hand over quite quickly. What we'll do is, if you do have any questions, if you leave them to the end of the presentation, but feel free to type them up as you go along, and we can ask Gordon at the end rather than interrupting, because we've got some music and some animations throughout the presentation this morning. Finally, could I remind you that we will be setting up a page on the Education Scotland Technologies website that you can go back and we'll be able to get direct access to these video clips and presentations again. So please feel free to share that as well. Great, I'll hand over to you.
Thanks very much, Kirsty. I'm Gordon Masterton, civil engineer. So what do civil engineers do? Well, civil engineers design or supervise the construction of the really big pieces of infrastructure in the landscape, like dams, reservoirs, water supply schemes, flood defences, really big buildings, sports stadia, and bridges. And it was bridges, I think, that got me inspired to at least consider engineering as a career. You might have seen in the news that the Forth Road Bridge was 50 years old just a few weeks ago, and there was some television coverage about it and old clips of the bridge being built. And I actually watched that being built because I come from a small village in Fife called Limecones, and virtually from my bedroom window I could see the Forth Road Bridge being built and emerging, and it was quite a stunning experience to see. And I've got an old slide of the first of those that you can see on the screen. And there's something about bridges. I think everybody likes bridges because they're very noticeable, very visible in the landscape. They last for a very long time. Next one again. We'll just keep running through these ones. These are all bridges that I've been involved with as designer or advisor at various stages. And we design bridges for a life of 120 years. So that means that they're going to last in the landscape a lot longer than I'm going to live. But it's nice at the moment to be able to drive around Scotland and other places and see some of the bridges that I've designed and been involved in, and be able to say to my family or my grandchildren now, "Hey, Grandad designed that bridge." They get a bit bored with that, actually. But anyway, it's quite a satisfying thing to leave the mark in the landscape. And not many professions can actually deliver what civil engineering can, to leaving an impact on the landscape in quite the same way. What you do, good or bad, lasts for a very long time. And it can be quite exciting when it just works and you create something beautiful as well as practical and functional. Now, the thing that completes the picture, if we'll pause on that one though, is that the company that I work for, Jacobs Engineering, is now the engineer that's been responsible for the design of the new bridge that crosses the Firth of Forth. We're calling it the Queen's Ferry Crossing, and that'll be a cable-stayed bridge sitting alongside the Forth Road Suspension Bridge, which sits alongside the old railway cantilever bridge. So a fantastic collection of three of the exciting bridge types in Scotland in the same location. So really looking forward to seeing the Queen's Ferry Crossing taking shape. And when it's finished, it'll look something like that on the left of this slide. But it's got a bit to go yet. It's still under construction. A few more years till it's complete to this stage. But it's nice to see. One of the things that I did in my career was had a really interesting year as president of the Institution of Civil Engineers, and that's a sort of role that leads the profession for a year, I guess, and you get the opportunity to travel the world talking about how fantastic civil engineering is, which I really, really enjoyed. The first president was a man called Thomas Telford. He was also a Scotsman, and he was responsible for the Caledonian Canal and lots of the roads that link Scotland and England, and the Menai Bridge down in Wales. So he was a phenomenal engineer in his time. So it was nice to follow in his footsteps. I'm now going to look forward, and a few years ago I launched something called the Scottish Engineering Hall of Fame, and this is to celebrate engineers, the past and present, who've contributed something phenomenal to Scottish engineering. And the story behind that was that we induct every year at the James Watt dinner in Glasgow, we induct 3 or 4 new engineers into the Hall of Fame. And previous years we've had we're just going to show this up on the screen shortly. We've had engineers like Hugh Gill of Touch Bionics, and Hugh developed from an early idea by David Gow. He developed a really high-tech bionic hand. So that's not quite there, just about. There you go. Scottish Engineering Hall of Fame. There might be some audio coming up that goes with this. Hey! That's it. So, because it's a Hall of Fame, of course, just like Halls of Fame for musicians and sportsmen, you've got to have the fanfare music behind it before you make the announcements. Go on to the next slide. Are we now on to the main screen? I could probably run it from here. Now, I mentioned Hugh Gill as one of our inductees, and the hands that he designed are for people that have lost their hand, either in accidents or they work in the services and they've had combat injuries. But can you imagine having a fully articulated, designed hand, engineered, attached to replace the one that you've lost? Just what a fantastic, life-enhancing feature that is. And these are amazing designs. Another inductee was a chap called Douglas Anderson, who's also giving one of these glow meets. And Douglas's son lost the sight of one eye because a condition wasn't detected early enough. And he set out to design, with his training as an engineer, set out to design a machine that could give a better quality image of the retina in your eye. And that is now a company based in Dunfermline called Optos, which is doing extremely well. And they're not all men. One of our inductees is Dorothy Pullinger, and she's an engineer who was an automotive engineer in 1914, and she worked in the Arl Johnson Company and developed a car specifically for women drivers. And Dorothy Pullinger, what a fantastic story she has. But what I want to do is look ahead to 2035 and imagine that you're in the James Watt dinner in the hotel in Glasgow, and I'm just about to announce the winners of the Scottish Engineering Hall of Fame 2035 inductees. And again, because it's a Hall of Fame, you've got to have the fanfare. And the first inductee is Institution of Primary Engineers member, the engineer and inventor of the wonder material Caledonium that allows self-repair after damage. It never deteriorates. And unfortunately, Callum couldn't be here tonight because he's off on holiday in his island just off the west coast of Scotland. that he bought recently. It's called Iceland. The next inductee to the Hall of Fame 2035, Institution of Primary Engineers member, engineer, businesswoman, philanthropist, who patented the world's first efficient means of storing electricity without batteries, transformed the application of renewable technologies that could be stored. And finally, 2035 inductee, another Institution of Primary Engineers member. Surprise, surprise. The engineer who invented the portable water conversion process that made the deserts fertile again. So, not insignificant challenges, massive achievements, but they're kind of indicative of the challenges that engineers get involved with. They are life-changing, life-enhancing, and everything that civil engineers do is about improving the quality of life for us all. Finally, just like to give a bit of an insight into a project that I've been working on for the last 5 years or so. Been the government's engineer for a project called Crossrail, and that is the biggest construction project in Europe. £14.8 billion is being spent on this project over a 10-year period, and it's a fantastic job to be involved with because it involves large scale tunnelling. As you can see, the tunnel boring machines are about 7 metres diameter, tunnelling underneath London from west to east. But as well as that, there are bridges, of course, which I like. There are large stations built from deep excavations right in the middle of the city, and going up to high-rise structures on top of that. So it's got something for all aspects of engineering: civil engineering, structural engineering, mechanical engineering, electrical engineering, you name it, Crossrail's got part of it. And this next little clip is just about 3 minutes or so, gives a view of the scale of the project and the kind of activities that have been going on. So that's Crossrail. Next time you're in London, look out for the signs. You can't miss them right in the centre of London. A lot of the project's underground, but you see the stations and the activity going on around there. And that's civil engineering. That's my life in civil engineering. If you want to make a big impact on the landscape and you enjoy working in numerate subjects, science, mathematics, and you have an artistic interest as well, because the things that we do have to look good because they last for a very long time. Thanks.
Great, thank you very much, Gordon. That's brilliant. I'm not going to ask you to move back. We'll just sit here. And it's
You
like
okay
an
here?
interview.
Sorry.
It's like a newspaper interview. We've got some questions up that are quite interesting.
Good.
The first one from, I'm assuming it's Mr. Simpson's class, which is saying, what age did you begin engineering at?
Okay, that's a good question. I studied at Dunfermline High School, and I took physics, chemistry, mathematics, English and French up to higher grade standard, got good hires. So I had a free choice of the kind of subjects that I might want to take at university. And because I think of the inspiration of the Forth Bridge and watching that being built, and thinking of, right, how can I apply mathematics and science, which was probably my strongest subjects, how can I apply these to something really practical and meaningful and long lasting? And I looked again into engineering, and civil engineering was the subject. So I committed to that in the course that I took at Edinburgh University. So I would be about 18 or 19 years old at that time. What that course allowed at the time as well was a combination of civil engineering and architecture. So that particular one allowed me another year to make the final choice of whether I wanted to be an architect or a civil engineer. Kind of glad I chose civil engineering. I think I made a better civil engineer than I ever would have been an architect.
Great. Well, this is a related question, talking about the old Forth Road Bridge. And do you know how long did it take to build the old Forth Road Bridge?
That's now I'll have to think, and I'll probably have to check my facts, but it certainly opened in 1964 because they recently celebrated its 50th birthday. I think they started the process in 1958, so it was about 5 or 6 years in the preparation for that and the actual build. To do the bridge, remember, it wasn't just the bridge structure that had to be built, there was the approach roads on either side, blasting into the hillside on the North Queensferry side, and building in on the South Queensferry side approach viaducts and a route to connect. So all of that adds to the general time required to build major projects like that. It's not dissimilar to the time required for the next Forth crossing, the Queensferry crossing, which has still got a few years to go yet before it will be open to the public. Crossrail is a 10-year build programme. It started in 2009 and won't be open to the public as a rail service until 2018 or 2019, when it's fully operational. So they do take a lot of planning and substantial periods in construction.
Another question here, Richard, was what's the best project you've ever been part of developing or part of?
The best project. Well, I really like, I suppose, I don't know if it's the best, but for me it was special. It was after I'd spent some time in the north of England working as a project site engineer on the Kielder water supply scheme, and I was responsible for 8 kilometres of tunnel and the outfall works leading into the River Tees in the north of England. After that, I spent a year at Imperial College in London doing a master's degree in concrete structures, and I came back to work in the bridges section in Glasgow, and I think from that point on being allocated the first bridge where I was responsible for the development of it. That was quite exciting, and it was a bridge down in Dumfries, right in the middle of the town, the Clew Street Bridge, and it's an old bridge, but it needed significant adaptations. So the approaches had to be sweetened so that double-decker buses could go round the corner from the white sands without encroaching on oncoming traffic. So there was a big benefit to the town when it was finished. And also, when we were working on that, we discovered that the old bridge actually needed quite a lot of TLC, and a fair bit of repair was done to the bridge at the same time. So we refurbished the deck and the structure and the parapets, and made it look as if it was still in the style of the old bridge, but it was fully restored. And that's still operational now, and that was one of my favourites. I won an award at the end of it, so that cheered me up.
Makes it memorable.
Absolutely.
Another question linked to that: how many bridges have you designed?
No, I haven't actually counted them. I would say approximately, given that when you take a project like a road bypass or a new piece of motorway, there are actually quite a lot of bridges on that, and you're responsible for heading a team that designs could be easily 12 to 15 bridges on one single project. So as I moved on in my career, I developed from being entirely responsible as the main project engineer for one bridge to leading a team of bridge engineers that would then work in parallel on a whole family of bridges for a bypass or a new motorway. And then you start to share the responsibility, because that's another good thing about engineering, is teamwork. Yes, I would be responsible for the concept design and the idea and the look of the final bridge, but I'd have a team of engineers working on the calculations and the design and the modelling of the bridge, and they can also claim that they've been responsible for the design, and they have been. So the whole team starts to take ownership of it. In answer to your question, thinking about how many does that mean if you take the team and the individual ones, I guess I don't know, about 50 or 60 perhaps, something like that.
Quite a considerable amount. Quite a considerable amount to point out to your grandchildren.
Exactly so. They do get really fed up, especially in Scotland, because most of them are in Scotland. Not all of them.
A few questions here about the Hall of Fame, asking how many people are in the Hall of Fame.
Good question. We started in 2011, so we've had 3 years of inductees. In year 1 we inducted 7 because we needed to capture the really great names in engineering. James Watt, who developed the steam engine into something that transformed the Industrial Revolution and made Britain the wealthiest country in the world. A lot of that was down to James Watt from Greenock. So we inducted 7 in year 1 and 4 in each of the years after that. So we've now got 15, and watch this space, because the James Watt Dinner 2014 is a week tomorrow, 3rd of October, and there'll be 4 new announcements for the new inductees into the Hall of Fame a week tomorrow.
Lovely.
If you're watching it live.
Can I just ask you to slide the mic between yourself and
Yes.
A LinkedIn question to that: are you in the Hall of Fame?
No, definitely not. I'm chairman of the judges, and I am not I'm not considering myself for inclusion in the Hall of Fame. There are far more exciting and interesting engineers out there.
Another question here, which is good. It comes into 2, Mr. Simpson's class again, asking what inspired you to become an engineer, but also I think you talked a wee bit about what inspired you at the beginning of the presentation, but what's fun about being an engineer?
Well, that is a good question, and I suppose a measure of that is, when you wake up in the morning, do you wake up thinking, fantastic, it's a day I can go and work on engineering and think of new challenges to solve and problems to solve. Engineering is about problem solving every day of your career, because you're taking on challenges like how to get a road across an obstacle, in the case of a bridge, or more maybe complex and systems-based problems, and how you get a body of people in the outskirts of London into the centre of London and back on a daily basis. So you've got to choose the best route and the best mechanisms, and you've got to decide on whether to go above ground or below ground, and you've got to do it in a way that is usable by the public. I headed up an environment business for a good number of years, and that included water treatment and water supply. And those kind of challenges are different. They're about making sure that the facilities in the area are producing clean water on a turn of a tap. And there's a lot of engineering goes behind that turning of the tap. There's billions of pounds worth of investment in dams, reservoirs, pipelines, water treatment works, in order to get that water from its source to everybody's home. And that's all engineering, and we do tend to take it for granted because we've grown up in a developed country. I worked for 2 years in Malaysia in the mid-90s, and I could see a different perspective on engineering there, because they were quite advanced, but in parts of Malaysia they were still developing their infrastructure. And so when you brought a water supply treatment works to an outlying village in a country like Malaysia, that totally transformed the life expectation of everybody that lived there. So that's also quite a satisfying aspect of being an engineer. If you get the opportunity to go overseas, you're not just making small scale improvements on the quality of life, you are absolutely transforming the quality of life and adding decades to life expectancy.
A few questions here that are all linked together as well. What can I do if I want to be an engineer, and do you have any tips you can pass on to help us?
I think the main thing is be interested in creative problem solving. That's critical. There is a competency in science, technology, engineering, mathematics that would be expected. So being adequately schooled in mathematics and physics is certainly an advantage, and using that to then go to further education. Doesn't have to be university. A lot of the best engineers that I know didn't go to university. They left school and started an apprenticeship, either in a construction site or in a consulting engineer's office like mine, and then took day release, HNC level qualifications. And good thing about engineering is that you can actually bridge across, and some of those youngsters that left school, joined me as an apprentice, went on to successfully get their qualification in HNC, part-time working. They then went direct entry into university and graduated with a degree, and I know at least one of them who went on to become a PhD and as a really top-class engineer, and was a late developer, I guess, but was inspired by the subject once he left school and started working in it. So there are many routes to becoming a fully qualified engineer.
Yeah, I think that's really important to remember, isn't it? That decisions you make now, you can change your mind later on. You can start off doing one area and then be inspired by seeing your bridges and think, I want to do that. Great. A couple of more questions coming in here. Charlie's asking, what's the hardest project that you've worked on?
The hardest? That's a difficult one. There are some. I think I showed a picture of some of the cable stayed bridges that we've designed, and they're not hard now because of the power of computers, but you have to be very careful with them in the way that you construct them, so that the buildability of these bridges has to be fully taken into account in the calculations that you're applying for the design, because they're at their most vulnerable stage when they're being built. Once they're built, they're secure and stable, and they've gone past the critical stage in their safety vulnerability. So it's it's quite hard to work out the various stages that have to be analysed by the team that are doing the calculations or running the software programs to make sure you haven't missed anything in the development. Another quite challenging one was there was a project that we had a technical advisor seconded into a contractor team, and that was replacing the bridge bearings on the Kingston Bridge in Glasgow a few years ago. And that was a very, very high-tech, complicated exercise because the entire bridge at each end had to be supported on hydraulic jacks for a period of time while the bearings were replaced. That's the large steel components that the bridge deck sits on. And it wouldn't be very noticeable to the outside world, but underneath that bridge for a time, the whole bridge was sitting on hydraulic jacks effectively. And that was a very, very safety critical operation. If it had gone wrong, the bridge could have collapsed in the middle and there would have been a lot of embarrassment. And, that's the other aspect about big engineering, is that if you don't get it right, there are consequences. But it's really satisfying when you get it right and it works and it gets back into functionality.
Another question from Rhiannon this time is asking, what do you like and dislike most about being an engineer?
What do I like most? I think it's the legacy. It's the fact that you spend a lot of time working in an office or working in front of a computer or developing a design, and the computer drawings get produced and then they get sent off to a contractor to build them. And then you can go visit your ideas taking shape out in the countryside somewhere, and you visit it over a period of time until it's finally complete. And that is incredibly satisfying. That's what I like about engineering, seeing your ideas, the things that you've dreamt up in your head, intellectual concepts, transfer through the medium of drawings and computer-aided design into something physical that's going to last a long time, a lot longer than me. But what I don't like, what I dislike about engineering is that it's not as understood by the general public as it should be. I think we tend to take engineering for granted. You come into your house after being out, you put the light switch on, and behind that single action of putting the light switch on, there is a highly complex engineering system providing the power to electricity substations and a network of cabling and safety systems that make sure that when you turn it on, you don't get an electric shock. It's a phenomenal bit of engineering that we've created, but we take it for granted. So that's what I don't like about engineering.
Yeah. I always think that when I see a plane landing, in Edinburgh normally is where I'm watching planes land, and I always think that we completely underestimate how amazing that is. That we've been able to do that.
Absolutely.
So all of those little things as well that seem really little, but have all added to that. Interesting one here. Well, two questions. One, do you know how many people, Vinny's asking, or do you know how many people are involved in the new Queensferry Bridge?
A lot. Yes, a lot, because there's the people that are directly employed in the site cabin, they're based in the site huts, the site cabins. And they're quite large, 3 stories. They moved them up from the Olympics project in 2012 after they were complete. So there'll be several hundreds, if not more than 1,000 people actually directly employed. But engineering has a long supply chain, what we call a supply chain. So everything that is fabricated there has actually started its life somewhere else and had to be brought on site. So steel components are fabricated, they could be as far away as America or Korea or Europe, and the steel is rolled first of all from its molten state, and then made into shapes, and then fabricated into geometries and structures. So there's an awful lot of people involved outside the bridge crossing site itself. The supply chain is usually 5 or 6 times as big as the number of people working on the site. Now there will be official figures, and I don't know what they are. I can quote you them for Crossrail shortly, but there will be figures for the Queensferry crossing as well. I would estimate it will be about 3,000 or 4,000 people that have been involved in it and touched by it. For Crossrail, it's 14,000. Bigger project, spending more over a 10-year period, so it's about 3 times the size, 2.5, 3 times the size of the project for the new Queensferry crossing.
Questions here. We'll try and bundle these questions together as the last couple of questions. Maisie is asking, what is your next project that you're going to be working on?
Maisie, my next project will be retirement.
Well, that follows on to another question which Owen and Aidan have asked, which is, sorry, it was Millie asked, how longer do you think you'll be an engineer for?
Yes, once an engineer, always an engineer.
Yeah.
But certainly the end of my planned career with the company is quite coming soon. So watch this space. But yes, if there are things that I can do to help engineering, wherever, more in perhaps in the promotion of engineering and the benefits, and working with charities, that's the next project really. I've thoroughly enjoyed being an engineer over all my career, but it'd be nice to give something back as well.
Inspire the young people that
possible,
are watching this as
if
well.
possible. I hope I haven't put you off.
I'm sure not.
Can I ask a question?
Yeah, of course you can.
Yeah.
Just an interesting thing popped in my head is, do you find that your profession as an engineer has an impact on your domestic decisions? You know, if you're planning a new kitchen,
Oh
extension
yes,
to the house.
yeah. I think that's a fair point. Yes, you can't undo your engineering knowledge, so you do tend to apply your skills and project manage activities at home. And I've done that quite recently in building
Right.
extension, and kind of supervised it remotely. The builders don't like it very much. The other aspect we take home is safety awareness,
Yeah.
and engineering. Fundamentally, the first and major objective of any new project is to make sure that whatever it is we're doing, we do it safely. And the new Queensferry crossing and Crossrail are good examples of that. And we've changed our approach to that and our attitude to acceptability on that quite dramatically. Some of the video clips of the Forth Bridge being built 50 years ago, you see men walking on the catwalk, and it doesn't look as if they've got any harness attached to them, and there is absolutely no way that would be contemplated today. So we look after people that are building our projects far better, and we take that home as well. The safety consciousness and things that you do in your garden or in your house is something that sticks with you. So you learn life skills as an engineer as well, and as a result you're a safer person.
Insurance companies will like you more. Great. Okay, thank you very much. That's been really interesting. I hope you've all enjoyed listening to Gordon, and we will, as I said, this is recorded, so if you want to go back and watch again, or if you want to tell other people about it, please do that. And thank you again, Gordon.
It's been a pleasure.
Bye.
Great fun.